Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 32. Today we're going to talk about the properties of midsegments. We'll define what midsegments are, and then we'll look at the midsegments of triangles and then trapezoids. So the segment that connects the midpoints of two sides of a triangle, if we're looking at this triangle, halfway in between, and then the connecting between those two midpoints, that's the midsegment of the triangle. And we have more than one in a triangle. If we mark the midpoint here, we can have one there and one there. So there are three midsegments of a triangle. Similarly, the segment connecting the midpoints of the two non-parallel sides of a trapezoid is also called the midsegment. So in a trapezoid, these are the parallel sides. So the midpoints of the non-parallel sides, and when we connect those, that's the midsegment of the trapezoid. In this lesson, we will discover some properties of, you guessed it, midsegments. So our first investigation is going to be on triangle midsegment properties. We just need patty paper and a pencil. You're going to draw a triangle on the patty paper, and then using the patty paper, pinch the midpoints of all three sides and draw in the three midsegments. We should have four smaller triangles now within that bigger triangle that we started with. Copy that entire picture onto another sheet of patty paper. So you'll need two sheets for this investigation. Compare all four triangles by sliding the copy of one small triangle over the other three triangles. Go ahead and repeat that with a different shaped triangle. Mark all the congruent angles in one drawing. What conclusions can you make about each midsegment and the large triangle's third side using the corresponding angles conjecture and the alternate interior angles conjecture? Then compare the lengths of the midsegments to the triangle's third side. How are they related? So here's our investigation. I drew 3 points to draw a triangle, and then I'm folding. Didn't look quite in the middle, so I'm folding to find that midpoint. And then I'm folding again to find, so 3 midpoints, and then we're connecting the midpoints to get all the midsegments. You then want another piece of patty paper, and you're going to trace that whole design onto another sheet of paper. I was aiming for a scaling triangle. It might be slightly close to isosceles, but if you look, comparing all these different triangles inside, all of them are congruent. So now I'm going to mark congruent angles. We have that top angle, and we have one side, and then we have the third side. I'm going to measure. So a little over 10, slightly over 5. That first one was a little over 6 and slightly over 3. In other words, you should be finding that that midsegment is half of what the third side is. So what are some conjectures that we can use here? Well, when we divided the triangle with the 3 midsegments, we found that it divided the triangle into 4 smaller congruent triangles. When we compared our two pieces of patty paper over and over, we found that we had congruent triangles within that big one. And then the mid-segment conjecture, if we looked at what angles were congruent and how they're related, we should have found that the mid-segment of the triangle is parallel to that third side. And it was half the length of the third side. So the mid-segment is half the size of that bottom, or the side, wherever you turn it. Now let's look at trapezoids. Our second investigation we're going to do in two parts. So we have a trapezoid mid-segment properties. First, we're going to need to draw a small trapezoid. Draw it towards the left side of your patty paper for the rest of the investigation to work well. And then pinch the paper to locate the midpoints of the non-parallel sides. Draw in the one segment that a trapezoid has. Then we're going to label the angles 1, 2, 3, and 4. We're going to put a second piece of patty paper over the first and copy the entire trapezoid and mid-segment. Then compare the trapezoid's base angles with the corresponding angles at the mid-segment by sliding the copy over the original. Are the corresponding angles congruent? What can you conclude about the mid-segment and the bases? If you want, draw a second trapezoid and repeat your conclusions. So here's what that looks like. I again used my ruler to make sure that those sides were parallel, and I drew them any length I wanted so that I could connect the trapezoid. Now I'm folding to find the midpoint of those non-parallel sides, marking them and then drawing the mid-segment in. 1, 2, 3, and 4 for my angles. Then I'm going to trace this trapezoid onto another sheet of patty paper. Now I'm going to compare. I can see that those angles are congruent. Those angles are congruent. That means those three sides are parallel. I mean, the two parallel bases and the mid-segment are all parallel to each other. So let's keep going. The mid-segment of a triangle is half the length of the third side. That's what we found in the first investigation. So how do you think the mid-segment of a trapezoid compares to its bases? In our picture, one base was short and one was very long, and we know that the mid-segment was between the two. So we're going to start with the original trapezoid you drew. Extend the longer base to the right by at least the length of the shorter base. So go ahead and draw that base all the way off the paper to the right. Now slide the second patty paper underneath the first. Mark the sum of the lengths of the two bases. And then, using that second piece of patty paper, compare the mid-segment into the sum of the two bases. What do you notice about the length of the mid-segment and the sum of the lengths of the bases? Here's what that looks like. Here's our trapezoid. I'm going to extend that base out to the side. I'm then going to mark where the sum is of the two bases. Now I'm going to compare that mid-segment, and I found that the mid-segment fits into the sum twice, or the mid-segment is half of the sum of the two bases. So we're going to combine our observations from the last step in the first part to the last step in the second part, and we're going to come up with one conjecture for trapezoids. The mid-segment of a trapezoid is parallel to the bases. So that's what we discovered in our first part by comparing the angles. We found that that mid-segment is parallel to both bases, and it's equal in length to the average of the two bases. In other words, the sum of the bases, so base 1 plus base 2, divided in half would be the average, and that is also the length of the midsegment. So remember we said that 2 midsegments fit into the sum, so the midsegment was half of the sum. So this is the sum, and that's half of it. That would also be the average length of the 2 bases. So consider a trapezoid where you slide one of the top vertices to be on top of the other vertex. Wouldn't that make it a triangle? So here we have a trapezoid. If you keep pushing E so that it's on top of T, we would make a triangle. What would happen to this midsegment? Well, the average of RA and point T has no length. So average would be you cut that in half, and that's what the midsegment is of a triangle. Here on a trapezoid, we have a distance in the top and a distance in the bottom, so when we put them together and average them, that's what our midsegment is. So do you see how these are related?